Good evening and welcome again to the week 6 live interactive session. It is the problem solving session for the NPTEL course Transition Metal Organometallic Chemistry Principles to Applications. So in this course, we have already completed 30 lectures of this course, as it is a 12-week course and each week we have 5 lectures, so total we have 60 lectures in the course. So out of which we have already completed the 6th week of this course, and that is the 30 lecture we have already completed. So far we have built our knowledge starting from the discovery of organometallic compound and their structures, bonding with transition metals and their reactivity, and finally their applications in different fields. In application part, we have discussed little bit about catalysis and majorly with the activation reaction, that is the CH activation, CC activation, CF activation, out of which first we have read the CH activation reaction, which is more easy or more facile to happen, but the control, the reactivity of CH activation and functionalization requires some well designed catalyst. After that we have moved to the CC activation reaction. We have seen that the bond energy of CC is less than CH bond, where CH bond energy is 410 kilojoule per mole, whereas the CC bond is only 350 kilojoule per mole. Instead of having less bond energy, the activation of CC bond is very much challenging because of the system less number of CC bond is present. Also the CC bond are present inside of the system, that is they surrounded by the CH bond. That's why the formation of transition metal CC bond, the pre-complex, is inhibited. That's why there is another challenging bond is CC is difficult to active. We have reached to a certain condition and we have developed the transition metal complexes to active the CC bond. The next challenging part is to active the CF bond. CF bond is the most strongest bond and having the 450 to 500 kilojoule per mole energy. Instead of having high strong bond, we have also seen some example in last series, that is week 4, week 5, how CF bond can be activated through the bonding of transition metal complexes. So in this week we have discussed the mechanism of CF bond activation, and then we move to ourselves to the another system, that is the transition metal alkynyl system, that is or aryl system. So far now we have okay. So welcome again to this course, live session of interactive problem session, that is a problem solving session of the NPTEL course Transition Metal Organometallic Chemistry Principle to Application. So as per my discussion, so we have moved to we have already discussed the different activation reactions, like we have discussed the CC activation, CH activation reaction, then C activation reaction, and at last we have discussed the CF activation reaction. So these are called transition metal alkyl complexes. Now in this week, this is week 5, week 6, from week 5 to 6 we have moved to ourselves to, that is these complexes having sp3 carbon. So transition metal is bonded to sp3 carbon atom. So in the next week we have moved to ourselves to the bonding of transition metal alkynyl or aryl complexes, which has carbon atom having the hybridization sp2. So in this week we will mainly discuss through this problem solving approach transition metal alkynyl or aryl complexes, that is having the sp2 hybridization. Before starting the problem solving session, first I will discuss the mechanism of CF activation reaction. Then with the example the activation of C6F6 in presence of H2 plus Et3N trithylamine in presence of a rhodium catalyst Me3P whole 4 RH at only 95 degrees centigrade and 6 bar pressure to give the CF activated as well as functionalized C6H5, that is this, with the leaving of Et3NHF. So this so now we are discussing the mechanism of CF activation reaction. After that, we will start discussing the some sample problems, and I will show the solving how to solve them with different approach, and then to understand the week 6 content in more detail. If you have any question, you can ask me in the direct in this session, or if you have any other question regarding the lecture videos from the professor, please ask your doubts on the discussion forum. We will try to answer the discussion forum questions as early as possible. But when you are having doubt, please mention the lecture number as well as the time at which point you have the doubt. So after discussing the mechanistic cycle for this CF activation reaction, I will move to today's problem solving session. Today we will discuss about 15 problems after this discussion regarding the week 6 content. So first we have our active catalyst L4 RH that is the hydride complex is first loses one ligand this arrow will be up, this will be down. Okay, to give our active catalyst L3 RH. So then this active catalyst will do the catalysis. So now we have C6F6 and we have the base, that is trithylamine. This will convert these to base plus HF and then this C6F6 now we can coordinate to our metal. So this will be L3RH C6F5. Now we need to add our functionalization reagent, that is H2. Now we can see that the oxidation state of rhodium here is only 1, class 1, because of this C6F6 moiety which has a negatively charged. So now after the addition of H2, this step is called oxidative addition. So this will give our octahedral rhodium complexes with hydrogen L, hydrogen HH L, C6H5 L, and then it has the oxidation state of plus 3. So this step is called the oxidative addition step. After that it will go to the our active catalyst by removing of our desired product, that is C6H5H, that is the functionalized fluoroalkene or fluoro complexes. So this is the very simple mechanism, and this step is called the reductive elimination. So here the oxidation state of the metal again changes to 1 from 3. So here 3 very simple steps involved. So with that I think this is clear for this CF activation mechanism. I welcome again to this problem solving session for the course Transition Metal Organometallic Chemistry Principle to Application. So week 6 we have covered the CC activation, CH activation, as well as the CF activation, that is the all different types of sigma alkyl complexes, and we have moved to the sigma alkynyl complexes, that is we have already completed transition metal to complexes with carbon having sp3 hybridization, that is CH, CC or CF. Now we move to transition metal carbon complexes with sp2 hybridization, that is the alkynyl or aryl complexes. So now we have the first question regarding the CH activation, which we have already discussed in detail in last 2 classes. So question 1 is the cleavage of CH bond during CH activation by the transition metal involved. If you know the answer, you can just unmute and tell me.
Acoustic interactions.
Option number B. Okay. This is the only option. Okay. So again, this question have the multiple options which are correct. So I request whoever registered for the exam after getting your correct answer in the option, please read all the options. So there is a possibility to having more than one correct answer in a question. So simply this question also have the cleavage of CH bond during the CH activation by a transition metal involve obviously the agostive interaction. Again, this cleavage, after the cleavage of this CH bond, the metal center get oxidized. That is, the oxidative addition is also happening in this step. So agostive interaction is the reason to cleave the bond, and after cleaving the bond it's become oxidatively added to the metal center. So the oxidative addition also involved in this step. So the option 1 is also the correct answer for this question. So oxidative addition as well as the agostive interaction is the cause that is required to active the CC bond, and after activation it breaks the bond to undergo the oxidative addition to the metal center. So both the process involved during the CH activation reaction. Is this clear?
Yes, sir.
The next question is the application of CH activation is. This is the very common question. I have also discussed this question in, I think, last series. What will be the correct answer?
Alkane functionalization, sir.
Yes. So here only one option is correct. Alkane functionalization. So can you give an example of this alkane functionalization? Very common example.
Alkane to alkyl halides.
No, just say particularly, not general alkane alkyne. Particular a compound to another compound. We have already discussed this.
Alcohol.
Yes. So we have methane CH4, which is the hydrocarbon, and we convert it to what? So this is a very good example of alkane functionalization. So we active this CH bond from the methane and convert it to the methanol. So this is a very good example of functionalization of alkene to give a very useful or value added product, methanol. Okay.
Okay, sir.
The question number 3 is the most challenging bond is to active HH, CH, CC or CF.
CF, sir.
Yes. What is the bond energy of CF? Okay. So CH bond has, so CF bond has bond energy around 450 to 500 kilojoule per mole. This thing you should remember when you are talking about the activation of CH, CC or CF bond. Then you can see how challenges a bond to active. Now Cc bond energy is only 350 kilojoule per mole, and then the CH bond is 410 kilojoule per mole. So we have also discussed that the CH bond has more activation energy than CC bond or bond energy, but the activation of CH bond is easier compared to the CC bond. Can you tell me one reason? Why CH bond is more challenging, a CC bond is more challenging in spite of, so bond energy, if we write bond energy of CC is less than bond energy of CH, but the activation of this CC is more difficult. Why? Can you answer this? According to bond energy, yes, you are correct. Most challenging bond to active is CF bond.
Due to steric hindrance
And
electronic factors.
okay, somehow correct. That CC bond, if I consider a simplest molecule like ethane, it has C2H6. So it has 6 hydrogen. Okay, so there will create a hindrance to approach the transition metal to the CC bond. Also, you can see that to one CC bond there is a 6 CH bond. So the number of CH bond is more compared to the CC bond. Okay. So in spite of having less bond energy, it is difficult to active the CC bond. Is this clear?
Yes, sir.
Okay. The next question is RF metal complexes, that is the perfluoroalkyl metal complexes, are stable owing to option A, MC overlap increased as a result of contracted metal orbitals arises from higher partial charge on metal, MC overlap decreases, lower energy pi star MO of RF facilitates, higher energy pi star MOs of facilitates metal to perfluoroalkane back donation or back bonding. This is a very important question. What will be the answer?
Option D, sir.
You are saying option D. Okay. So think about it. So our question is about perfluoro alkyl metal complexes stability. Okay, so we have RFM. I have already discussed this in the last series also, and I have another RHM. In both of them, there is a very interesting thing happens. Here, RHM, so generally both having delta negative and metal is delta positive. Okay, but we know that the electronegativity of fluorine is very much greater than electronegativity of hydrogen. That's why this perfluoro ligand will have more higher partial charge, that is more higher partial negative charge over here compared to that corresponding hydrogen analogous. So we can write corresponding partial negative charge, we can write delta minus of RF is very much greater than delta minus of RH, and we have our delta positive of RF M F, where the perfluorometal complexes, delta positive of M normal alkyl complexes. So as this negative charge, that is the partial negative charge, will be more because of this fluorine electronegativity, this positive charge in the opposite end will also be more, that is the charge separation will more strong, and it will, because and this will enhance the more partial charge on the metal center, and that's why the orbitals of metal center will get contracted, arising the higher partial charge on the, as the metal orbital gets contracted, so the metal carbon bond overlap of the two orbital will also increase. Okay, that is the energy factor because of this contracted orbital will increase the metal carbon bond orbital overlap. So orbital overlap increases because of the contracted metal orbital, because of the high partial charge, high partial you can write positive charge on the metal center. So here option A is one of the correct answer. The next one is, so as we know that as the electron density or negative charge increases on the ligand, if we have 2 pi orbital, that is RH, and if we have another pi orbital for RF, so this is pi and this is pi star, pi and this is pi star. So because of the higher negative charge on the perfluoro, the energy of this pi star, that is the pi star, will decreases. That's why the higher the energy of this orbital decreases, which facilitates more pi interaction with the metal. So, our question is, the lower energy pi star MO of RF facilitates the back bonding. So here two very important thing happens. One is, because of the higher electronegativity of the fluorine atom, there will be more partial charge on the RF, which will create more partial negative charge, a more partial positive charge on the metal center, and because of this more partial positive charge on the metal center, their orbital gets contracted, which will facilitate the more overlap with the ligand, that is the RF, perfluoroalkyl, and because of the more partial negative charge, the pi star orbital of these will also get contracted, and the energy of pi star gets lower down to facilitate the metal to perfluoroalkene back donation more facile. So option number C will be another. Lower energy pi star MO of RF facilitates the back bonding. This is a very important question to understand from this topic. Is this clear, or do you have any other doubt?
Okay, sir. Okay, sir.
The next question is, the cis orientation of the ligand is required for the reactions. The cis orientation, I think there was an assignment problem in the portal. Someone asked me in a live session about this orientation. There was a question with some metal complexes, that addition of hydrogen, which will be the orientation. So that time I did not explain it because the solution was not released. So this question is based on that. The cis orientation of the ligand is always required for which reaction?
Oxidative addition, sir.
Okay, very good. So here the cis orientation, let's say we have our metal M with L4. If we add hydrogen, let's say H2, this addition metal in plus 1, for oxidative addition it will have M, H, H, L, 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 L. So these two hydrogen is always added in a cis position. So again, this oxidative addition is one of the correct answer for this question. Another correct answer is the migratory insertion reaction. Though we not discuss this in this series, but we are going to discuss it when we discuss the catalysis. Some Wilkinson catalysis, some carbonylation reaction, monsanto acetic acid synthesis reaction. There we will have another term, migratory insertion reaction. So there also the cis orientation is required. So remember this question when we will discuss the different synthetic procedure of catalytic reaction like Monsanto acetic acid on all, when you read it, remember that the cis orientation for this is very much required for these two types of reaction during the mechanistic cycle. One is the oxidative addition, another is migratory insertion. The cis orientation is very much important. So migratory insertion, so let's say I think you have MCH3 and CO, and we have another L. Now the insertion of CO in the methyl group to give M, you can write here M CO CH3 and other L remain fixed. We are not discussing it here, this is just for example. So to give this insertion, this is called the migratory insertion reaction. It is the insertion of CO to a methyl group to give this CH3CO. For this also the migratory insertion, the cis orientation is required. The other ligand, or if the CH3 is present in other position, it is not possible to insert in a reaction. Okay. The next question is the reversal of polarity observed in. This is also another very important question. Methyl chloride, methyl iodide, trifluoromethyl chloride or trifluoromethyl iodide. What will be the right answer?
Option C, sir.
You are saying option C. Okay. Wait a minute, I will discuss. One minute. So we know that the halogen X minus are always exists in a negative form. That means whatever we write Rx X or Rx, there always should be positive charge on the alkyl group and delta negative charge on the halogen. But You may be aware of that one type of halogen we have which are called some species exist which is like I3 minus, Cl I2. These species also exist. So for the fluorine, if attached to the alkene moiety, that is the perfluoro alkene, can you tell me the correct answer? Perfluoro alkene, we have one term which we discussed in the lecture series, that reversal of polarity. Reversal of polarity. So for these complexes CF3, because of the high electronegativity of fluorine, again this generates a high negative charge. So this becomes highly negative charge. So these become delta negative. So which halogen should this? This is nothing but the iodide. The iodide one, because of its large size, it may have exist as iodide plus. So CF3, my delta minus, we have iodide delta plus. With that, we have also discussed one question. CF3 with and this negative charge favors the nucleophilic attack in the carbonyl metallites. This question I have already discussed in last session. So the reversal of polarity always observed for the perfluoroiodo species, not chloro species. So perfluoroiodo will be right answer. Question number 7 is, the metal to ligand pi back donation is least in. The metal to ligand pi back donation is least in lowest metal carbonyl complexes, that is MCO, metal alkyl complexes, that is MR, metal carbene complexes, mainly Fischer carbene. So Fischer carbene is AmCX, like that, and metal alkene complexes, that is M double bond.
Option B, sir.
Yes, metal alkyl complexes, because metal alkyl complexes you can see only consist of the sigma bond. There is no pi star is available on this alkene moiety to accept the donated accept the electron from the metal. It may be exist, but that are too high energy. So the pi donation for alkyl complexes will be very much least, whereas the other complexes carbonyl, carbene, alkene already have their own pi star orbital, so they can accommodate the back donated electron from the metal. Okay. The next question is between TiCH3 whole 4 and TiPPH3 whole 4, the stability. Which one is more stable, which one less stable?
Option B. Option B, sir.
Yeah. So option B will be correct answer. Why?
Because in a phenyl group, there is a back bonding is formed.
Yes. Very good. So here, for those who don't know the answer, but read this thing. I have told in last session also that don't skip any question after solving the questions which you can just solve it in first attempt. So the questions which you not able to solve in first attempt, when you come back again, just read the question and think about which option can be eliminated based on the statement. So here you can see that the two options from A, B, C, D can get automatically eliminated. One is the option number D. So here it's saying that the TiCH3 whole 4 has beta hydrogen. So TiCH3 is finished. This is only alpha. So there is no possibility of beta hydrogen. So this option D is first eliminate. Then as we are considering the stability of these two, then both may not stable because one is transition metal alkyl complex, another is transition metal aryl complex. The stability of these two cannot be same. So option C we can also eliminate. The only thing is remaining the option 1 and 2. So if you tick one of them, there is a 50% probability of getting the correct answer instead of 25% with all the four options. So here, because of the pi star, as I discussed in the last question, orbital in the pH4, the back donation is more possible here, which is not possible in CH3. So the titanium CH3 is very less stable compared to titanium pH4. Yes, option B is the correct answer. The next question is question 9. 1 minute. Why it is coming on the next one? 1 minute. Yeah. Now is this visible?
Option A, sir.
Yes. The product of the reaction is, with this reaction, so here it is a kind of, we can say it is a kind of transition. Here you can see this is a pi bond in the reactant, which is converting to a sigma bond in option A. Obviously option A is the correct answer. So in presence of HCl, this hydrogen will add here, and this will form a sigma bond with the metal. So this is a example of pi to sigma conversion in presence of HCl. So conversion of pi bond to sigma bond metal complex. So here that is transition metal alkynyl to transition metal alkynyl complex we are getting from kind of pi sp pi interaction. Okay, next question is question number 10. It is the same, somehow the same question like the previous one, just reagent is different. Reagent and reactant is different.
Option B, sir.
Option B. Okay, so why not option C?
In option C, the complex is having 16 valence electrons only. It is not stable, I think.
Yes, very good. You are getting an idea of stability through the reaction. So this complex is 16 electron complex, whereas this is an 18 electron complex with have just addition of one CO moiety. That's why option B is the correct answer, not option C. Okay, very good. Now the next question is from the carbene chemistry. The carbene carbon atom in Fischer type carbene complexes is
Singlet and sp2 hybridized, sir.
okay, very good. So the Fischer carbene type carbene is singlet carbene and it is sp2 hybridized. Okay. The next is for the shock type carbene. Option is same. What will be the answer? For Fischer carbene, you are right. It was singlet and sp2 hybridized. And for the shock type carbene,
Triplet and sp2 hybridized, sir.
yes. So shock type carbene is triplet and sp2 hybridized. So between the singlet and triplet carbene, which one is more reactive? What is the electronic configuration, that is how these two electron of this carbene, this is the two electron, right? So this is carbon having these two electron, let's say x2. Okay, this is the carbene, right? And it have two electron. So what is the orientation of singlet and triplet? And for the electron we are generally indicate like this. This can be plus half and the downward will be minus half. What will be the orientation of these two electrons in the singlet state and the triplet state? Do you know? So in the singlet state, all these two electrons will be paired up, and in the triplet state all these two electrons will be unpaired, and for the triplet state the pure p orbital it contains the two electrons, whereas in the triplet state it will have in two different p orbital. Okay, we will discuss this electronic configuration of triplet and singlet carbines in more detail in the upcoming session. Now the next question is the ligand which is not isoelectronic with, this is called the acetylide, acetylide, that is, this is called a acetylenic bond. Acetylene is HC triple bond CH. So if you remove one hydrogen from acetylene using a base because of acidic nature, it will give this ligand. The ligand which is, the question is not, which is not isoelectronic with this. Isoelectronic is very simple, just count the total number of electrons for each molecule.
Cp minus.
Yes, Cp minus. Then what? Tell me the total number of electron count for this. Tell me. You have, your answer is right. Cp minus. Hmm?
5.
How it is? How you are calculating? Now tell me.
So Pn and
Huh? Tell me if it is wrong. Even I make many mistakes in my exam, so that is not correct. That maybe my calculation may be wrong. You tell me how you are calculating. Hmm? Your answer is correct.
so Cp is of 5.
Huh? Cp5. There is a one electron. It is Cp minus.
Cp 6.
So this will be 6. And this one? Okay. So calculate in simple way. So this acetylenic moiety has one H, one carbon, another carbon, and one negative charge. So if you calculate the total electron for all the element, so this is 1 plus 4 plus 4 plus 1. So that is 10. For Cn minus, Cn plus 1 electron, it is 4, nitrogen is 5 plus 1, that is 10. We are only considering the valence electron. Then CO, carbonyl, CO is 4, oxygen is 6, valence electron, that is also 10. But here Cp has C5H5 minus, lots of electron. Okay, then molecular orbital will be very different compared to the CON to CN. So Cp has, if you calculate in terms of total number of electron, then you also get the, then may you also get the right answer. Okay. The next question is again is this. Why it is overlapping again and again. Next question, or I think this is, one more question is there. This is the second last question. What will be the correct answer? This is again on that CF activation.
To functionalize the perfluoro compounds.
To functionalize perfluoro compound, that is option number B. Again, I am saying, after getting the correct answer, don't stop reading all options. There are, this exam will be, or assignment will be, not only MCQ type. There would be some question which will have MSQ, that is multiple selection type. So one answer you got it, that is correct, you know it, you have confidence, that's good. But after getting it, don't stop reading all the options. Here the first option is to generate perfluoro compound. No, we already have perfluoro compound. We need to activate them. So option A is first cross. To functionalize perfluoro complex, yes, we are activating the perfluoro compound, then we are functionalizing it to other functional metal, like I discussed C6F6, and we have functionalized to C6F5H. Okay, to hydrogenate perfluoro compound. This may be, may not be. We are not doing all time because this molecule may not have the importance. Just for our chemical reaction we are doing. Here the only thing, the word importance. This is not what the application. If you say it is the application of CF activation, yes, we may hydrogenate it. But the word is important. This is importance of something we will not do which is not important. So hydrogenation may be important, may not be important. So this is also not correct. The last option is to generate the perfluoro compound into harmless substance. Yes, sometimes the perfluoro compound which have some harmful groups, and we need to convert this harmful compound to some harmless compound. That time CF activation is importance. So importance and application, these two words have different meaning. Application may be anything, whatever may not be important to you. Okay, so just like we are converting, let's say we are converting CH4 to CH3OH, methane to methanol. This is importance because this methanol have very valuable chemical. We can convert it easily to many other product. But let's say if I convert CH4 to CH3, methane to ethane, is there any importance? No, because that is an, we may use something which is applicable, application of CH activation. We may, by doing the CH activation, we can convert methane to ethane. That is an application of CH activation. That is an application. But all the application may not have the importance. So option D will be the correct answer. The word importance here is very important. Okay. The next question is, or the last question of this series, the carbene complexes. There is some four statement of carbene. Just say which one is right.
Option B, sir.
If you see or read carbene, then there is two types of carbene I have talked about today. One is Fischer type carbene, another is shock type carbene. So there is some difference between these types of carbenes. The here question is the carbene complexes. Carbene means any carbene complexes. You got the point, right? Not Fischer, not shock, nothing. It can be any heterocyclic carbene also. Okay, so you see the carbene complexes, the general statement, carbene complexes. So carbene complexes contains metal in low oxidation state. Yes. In which type of carbene it contains in low oxidation state? In shock type of carbene? In shock type of carbene?
Shock carbene.
Yes. In
Shock carbene.
shock type of carbene complex, it low oxidation state contains heteroatom on the carbene carbon. Which type?
Fisher carbon, sir.
Fisher carbon is heteroatom stabilized. Whatever. There is Fisher carbon which is heteroatom stabilized. Then contains metal center in high oxidation state. Again, chalk type carbon which contains metal center in high oxidation state. Again, contains C or H substituent on the carbon carbon. Again, chalk type of carbon. So here all options are correct. A, B, C, D. This is a general statement for carbon complexes. Okay? Is this clear?
Yes, sir. Yes, sir. Yes, sir.
So don't mention any one option. Here all options are correct because you don't know which carbon complexes you have.
Okay.
It may be Fisher type of carbon, it may be Schock type of carbon. If somebody mention if is Fisher type of, then you say, hey yes, Fisher type of carbon contain heteroatom stabilized and metal atom in low oxidation state. Okay?
Okay, sir.
Clear?
Sir, I have a doubt on that. In that questions, they asking a multiple answer question. They asking any intimation about the multiple answer question. Is it?
I did not get it. What you are asking?
In examination, they asking about it. It is this question is multiple answers.
Yes.
This question having multiple answers questions.
Yes.
They are intimate or any intimation is there or they didn't give any intimation.
Intimation means I don't understand.
In that because is there any other section is there? I think a separate section is there and the questions
So you have
are not there.
regarding the final exam question, right?
Yes, sir. Yes, sir. Yes, sir.
So question pattern final for the final examination. Then
yes,
if there will be separate section or not.
Yes, sir.
For
Yes.
multiple selection type, is there will be separate section. MCQ type, there will be separate section. Like this is your question, right?
Yes, sir. Yes, sir.
Okay. So for this question, I can only say I also don't know.
Okay, sir.
So if you really want to know this answer, you just post this question in the discussion forum.
Okay, sir.
Only then I can talk with the professor after you're getting the question in discussion forum. Then he will post the answer.
Okay, sir.
Because from this TSU, I also don't know what type of question will be there. Because in this year, there will be some new type of question. New type, not new type. There will be some new question, not the previous year, which is taking from 2018, 19, 17, whatever. So as per my knowledge, I know that there is some new question. And type I don't know. There will be, I know that there will be MSQ, MCQ, both type will be there. But I am not sure, or I am not sure about there will be another particular section for MSQ or MCQ, or it will be mix up like 1 to 100 question. There will be mix up of MCQ and MSQ. I am not sure about that. So I encourage you to post this question with your proper doubt that there will be an multiple section like for section 1 MCQ and the section 2 for MSQ, or there will be 1 to 100 question with all mixed up. You just post it, then I will talk or somebody will talk to the professor, other TS, and they will post the answer.
Okay, sir.
Okay? Because yes, this is a genuine doubt. Otherwise in exam you think this is an MSQ or which one is MCQ. Huh?
Yes, sir. Yes.
So you know na how to post in the discussion forum?
I don't know, sir.
Okay. So when you go to the course like this is I think last year course I am accessing because I don't have access to the current year. So this in this course you have an option. Okay, 1 minute. Let me open this year's. Uh, Let me open this year's course. This is the last year course. 1 minute. Your doubt is very genuine, and as a registered for the examination, you should know it, the exam pattern. You are accessing from this portal, right? This Swayam portal.
Yes, sir. Yes, sir.
You can see my screen, huh?
Yes, sir.
So here there is a tab. This is announcement about the course and Q&A. Okay, you can see that, nah? Can you see
Yes, sir.
Q&A? This one, this one. First announcement, then about the course, then Q&A. In click on the Q&A, it is ask you to being redirected to Google discussion forum where you can discuss your queries with the course faculty. So professor will directly answer your question as well as other student of this course. Do you want to continue? You just do the continue. And it will open a Google Sheet page. Discussion forum, yes. See, some many people have posted some question. Okay, okay. So I think this is I am accessing the last year thing. Okay, can you see my screen, right?
Okay, sir. Yes, sir. Yes, sir. Yes,
So
sir.
you this is 49. This is the last year. Okay. Okay, good. See, somebody has already asked some question. You can see. Huh? This is this year. No, not last year. So, to discuss the question, I don't know who is posting this. Okay. So, just to ask your question, you click on the new conversation. Huh? And new conversation, and this window will open. Your email address will be from, you write down the subject. Huh? The for subject you can write the related exam question pattern, and you write your question and just you post message. Huh? Okay.
Okay, sir. Okay, sir.
Just post your question, and here the post, after writing this post message will be enable, and you post it. Huh? And then we will answer it.
Okay, sir. Okay, sir.
Got it right? There already you can see there is some question. Huh? Let's say on August 21 somebody answered, somebody asks that in week 2 lecture 7 I have said that the early transition metal, but after few minutes he said late transition metals, and why it is so. Okay, so you can post your question here and they will clear your doubt.
Okay, sir. Okay, sir.
Because I am just for this only doubt related to the content I can clear. So if my clearance is not good, you cannot understand, then also you can post your doubt. Let's say someone has posted it is nodal plane or plane of symmetry. So you can also post your doubt in here. I encourage in every session that don't be quiet, post your doubt.
Okay, sir. Okay, sir.
If you have any doubt regarding the, not my presentation, whatever my series or my live session, you post, ask me your doubt directly to me in the live session. Don't post my videos doubt to there, because that doubt is only for the professor will directly answer the question. And for my series,
Okay,
whatever
sir.
I am question and answer, whatever I am doing, you just directly ask me in the live.
Okay, sir.
You join this group, here is option join group, become a member of discussion forum. Then you will also, when somebody asks a question, you will get an answer. You will get the question and get the answer. Also you post your this new conversation by click on the Q&A, you go to this forum, and with new conversation you create your question. Okay, is this
Okay, sir.
clear?
Okay, sir.
I think you will get your answer within few days or few, let's say, this is very delayed, so I wish you will get your answer quickly.
Okay,
Okay.
sir. Okay, sir. Okay, sir.
Any other thing? Any other question you have?
No, sir.
Okay, then thank you.
Thank you, sir.
Okay, so today I also show how to ask question in the discussion forum. So please use this discussion forum to ask question related to this course content. If you have any doubt relating to this my content, whichever I am problems or questions which I am showing, you directly ask me. Don't post this thing to the discussion forum. You just ask to me. I will have, if I am not able to do, then I will in that particular live, but I may not able to do or may be able to do. If may not, then I will discuss that question in next session. Don't ask my question in that discussion forum. Discussion forum is only for the lecture videos taught by the professor. Okay, so I today I also show how to ask question in the discussion forum. I hope this will be helpful. Also the question which I discussed today will be also helpful to solving the problems or assignment, solving the problem or assignment. Throughout the course. So if you have any question like exam pattern or something like that, please post your question in the discussion forum. Professor or the other TAs will answer it according to the guidance of the professor. Okay, I hope this session will be helpful. Whoever will watch this from the uploaded version, so I encourage please join encourage please join in the please join in the live session, so that you can ask me, you can interact with me with your doubts regarding this course or the chemistry career or anything regarding this course knowledge. Or if you have any doubt regarding the content, original content of the course, just post this in the discussion forum. You will get your answer cleared from the directly from the faculty. Okay, I hope and this will be helpful to the viewers who will watch this from YouTube. Or I am thanking you again for joining in this series. So if you have any doubt of this course content, please you can join in the live session every Tuesday throughout this course from 6 to 8 p.m. Thank you.